Welcome to solverfy.
This is the answer to Chapter 27, problem number 26 from the Smith Organic Chemistry textbook. And so this problem is asking us about electrocyclic ring openings. And it's asking us to consider the different products that will be formed under the two different types of conditions that we've talked about all throughout this chapter. So thermal conditions versus photoelectric conditions. And so for each of these electrocyclic ring openings, remember, it's just the same type of electrocyclic reaction we've been talking about. So electrons are going to move all at once and all around. And so since we're starting from a ring, we do need to consider the number of bonds, the number of double bonds in our products, as opposed to the number of double bonds in our starting materials. And so for A, we'll look at thermal first. And so when we do this under thermal conditions, the ring will open. And so we can draw this backbone where the ring has opened. And we have 3 double bonds now. So 1, 2, and 3. There they are. Our methyl groups over there on the left side are going to be unaffected. And then we need to think about whether this is going to be conrotatory or disrotatory. And so, like I said, we need to consider the number of pi bonds in our products. And so here our product has 3 pi bonds. And so 3 pi bonds, odd number. And so this is going to be a disrotatory rotation that we're looking at. And so these both start coming towards us, and so they're going to rotate in opposite ways. So this one will end up going up, this one will end up going down. And so again, like I said, this will be disrotatory. So we know that since thermal in this instance is disrotatory, we know that photoelectric is going to have to be the opposite. So conrotatory, and again, the product is largely going to look the same. The carbon sort of backbone of the molecule will be exactly the same. So there we go. Let's put our double bonds in, 1, 2, 3. And then now what we need to consider is the stereochemistry here. And so again, they both start over or coming out of the page, if you want to call it that. And so they're going to rotate in the same way. And so up and up. And so the top bond here will be trans, and the bottom bond is going to end up being a cis double bond. And so that's our conrotatory rotation. And then so when we look at B, everything's going to be exactly the same, except that the 2 methyl groups that we're looking at are starting trans to one another. So everything's going to be just exactly opposite of how it was in part A. And so when we do the thermal electrocyclic ring opening, we'll get this same sort of backbone that we've been considering. 1, 2, 3 double bonds, those 2 methyl groups, and then we'll actually get the same exact product as we got for the photochemical ring opening from A. So there's the thermal product from B. Like I said, it's exactly the same as the photochemical product from A. And so again, thermal, it's going to be disrotatory. But since these methyl groups were on opposite sides of the molecule, and they're going to rotate in opposite ways, now they're both in the same orientation. And so conversely, the photochemical conditions are going to give us the same product as the thermal conditions gave us in A. So we can draw the backbone of our molecule, put our 3 double bonds in, put our unaffected methyl groups in, And then again, these are starting trans, but they are rotating the same way. And so they're going to also have opposite orientations in the product. And so they do. And that's the answer for B. And that is the answer to chapter 27, problem number 26.